I've been annealing for quite a few years now, starting back in the fall of 2018, and it started with nothing but a torch and a socket in the end of my drill to test some neck tension issues I was seeing. I soon realized that it did work and solved that issue, but it was glacially slow. At this time, my shooting hobby was starting to change as well, going from loading a lot of blaster ammo and focusing a lot more on how accurate can I make my rifles. I purchased my Annealer's version 2 in January of 2019. I did add a switch and a voltmeter to make it easier to set up and use. I will say if you're looking for a turnkey solution, Jeff at Annealer's is probably one of the best US made, reasonably priced annealers out there that you can set it up, load it up, and let it run. The new V4 looks like a great machine, and they are constantly improving it with every new version. Up until just last fall, it worked great on short action stuff like 308 and shorter with no issues. But I was seeing some issues with 300 PRC and getting brass to consistently anneal, as well as the time to anneal due to a much larger case was becoming an issue, even with the Magnum-sized wheels. I didn't take any video of it, but the cases would not turn evenly, resulting in some hot spots, and due to a single torch can only get so hot, the time per case was getting excessive. For reference, a 308 case would anneal just fine at about 5 volts, but the 300 PRC was set at about 2.5 volts. After it taking about 4 hours to anneal 300 pieces of brass, I decided to find something else. In the past, I've looked for a used bench source which can use dual torches and is probably one of the nicer flame annealers on the market, and it appears it would be pretty easy to automate by adding a case feeder. But it is rare that they come up for sale at a reasonable price, and I'm honestly not even sure if they're being manufactured anymore, as nobody has them in stock. I've known about AGS for a while now in my looking around the internet at firearm related stuff and several forums that concentrate just on reloading. And for less than $300 shipped with dual torches, I decided to pull the trigger. The fit and finish are good to go, and it's all stainless steel or aluminum in construction. I did test the unit before I started with any modifications, and it worked as expected. Overall, the design is quite simple, and it looks like even if AGS were to go out of business, replacement motors that drive the wheel and case turner would be very simple to source from somewhere like Amazon. There are a bunch of other reviews on YouTube, which is I decided not only to review this system, but modify it as well. The feed plate is about a 1/4 inch thick and has 10 holes for the individual bushings that are set into it, as well as small locators for the detents that interface with the bottom. It's cleanly machined and a nice piece of work, to be honest. You can see I laid out where I needed to drill in 8/32 set screws to keep the inserts from spinning. You'll see as we get further into the video how it comes together. Also, if you look close, you can see I screwed up the layout, and I obviously fixed that before I started any drilling. Due to space considerations, I did keep the set screw on the leading edge of the insert, as I didn't want to hit the little drive pin that makes the plate rotate. Drilling was pretty simple. Just put it in the vise, drill and tap it for the set screw. In hindsight, I should have probably done a little better job with centering up the hole and keeping my layout line perfectly vertical, probably using the Bridgeport and setting up a proper jig, but in the end, it worked out good enough. There are 4 different sizes of inserts included with the annealer. Sizes are basically 223, 308/30-6, 300 Win Mag/PRC, 338 Lapua, and you can run it with no insert for anything larger. Due to wanting to automate it and getting it to feed properly, I removed about 1/4 to 1/3 of each insert that sits above the feed plate. I did this with my drill press in the garage with a standard 4-flute 1/2 inch end mill in combination with a 3D printed holder and a small vise. This overall went pretty well, but did create a pretty good racket, as the drill press obviously is not as rigid as a mill, and end mills really aren't the best choice for drilling. It did get it done though. From there, it was a bunch of cleanup with a small file and a Dremel, and they dropped right in, and I locked them down with the set screw. We all have points where hindsight gets us on a project, and in this case, yes, I would have been far better off using the Bridgeport to drill and tap in the set screws and slot the inserts. It would have saved me a lot of time doing the cleanup on the inserts at a minimum. But at this point, we were set up for some fabrication stuff on the mill, and I didn't want to tear down what we had going, clean up, set up to run my stuff, clean up again, and then set the mill back up for the project we were working on. So drill press it was. I'm adding this photo as a warning. The D10 sees a simple and effective 3mm ball bearing over a short spring. If you take this unit apart and attempt to reassemble without a large sheet pan or something similar underneath it, you will probably lose one or both. Don't ask me how I know. I lost one while I took it apart and 3 to 4 more during reassembly. Luckily, a bag of 3mm ball bearings is like $4 on Amazon. I have a Hornady case feeder, but the general setup on this is pretty much the same for a Dillon feeder. It just would require a slightly different adapter for it to sit on. The nice thing about this setup is it takes all of about 5 seconds to set my Hornady case feeder on top and be ready to anneal. In this photo, you can see that my annealer without the pipe cut down is significantly higher than I wanted. I put in the drop tube that I'm using, the one from my Hornady lock and load in this example, and then measured the difference. I think I cut the pipe down to 22.5 inches, put on the 3D printed adapter, and it was all ready. I needed to use a 1/4 20 bolt to hold the bracket in place, so I marked out where I wanted the bracket to be located and drilled a hole. The stainless steel is pretty tough, so make sure you have a sharp drill bit. I felt that the spot I put it would be the best for the case feeder, as well as keep it as far from the torches as it could be. The hole is a little oversized to give me some adjustability. This drop bracket isn't completely my design, as I use the APP bracket setup from the bullet feeder designed by Tyler in the community on Cast Bullets. I use this on my Lee APP and it works fantastic. I did have to make quite a few changes, but it did give me a place to start from. I added a holder to the bottom of the bracket so I would have a wiper to ensure the case would be brushed into the feed plate and not jam. This is nothing more than a piece of zip tie stuck through a hole I drilled into it. I did end up pretty much redesigning the drop tubes, and in this picture you can see the drop tubes for 223, 6.5 Grendel, 308, and 300 PRC. The first couple runs on being fed with the case feeder aren't shown here because it worked like trash, jamming and generally being a pain. As I made a few changes, it got better, finally running pretty well other than the jam you see in this short clip right at the end. I changed the orientation of how the drop tube sits in the bracket, clocking it just a few degrees counterclockwise, and tested again, and it worked much better with no failures when I ran about 100 cases through. You can also see quite here I'm using 308 size bushings for the 223. This ended up being necessary as I could not, even with multiple revisions, get the correct size bushing to feed without jamming. It results in the case spinning maybe 1/16 of an inch out of round, as you can see in the video. It's not a huge deal and really doesn't affect the annealing process. So let's start with a failure first. It ends up that the dual torches will melt plastic pretty quickly. I did some adjusting on the torches, changing their position, but I melted another bracket slightly less quickly, so back to the 3D printer. From there, I decided a heat shield would be in order. I grabbed a piece of 16 gauge steel from the scrap bin at the shop and figured out how big and what shape it needed to be and how I was going to attach it. From there, I just cut it out, cleaned it up, removing all the burrs, bent it into a shape I wanted, added a coat of paint, and attached it to the annealer. The heat shield does get hot, so you don't want it to be too thin. I wouldn't go thinner than 20 gauge, to be honest. Obviously, a piece of stainless steel or aluminum sheet would work fine for this as well. The heat shield was a success and prevents the 3D printed parts from melting. From the video, you can see I have the torches in the outermost position, so I'm getting the least heat on the shield. As far as annealing goes, it's fast. I'm running at 70% of total speed for 223 and at 45% for 308. It's significantly faster than a single torch for obvious reasons. I don't have any Grendel or 300 PRC brass that needs annealing right now, so I don't have the numbers available for that. I might play with torch positions a little bit for each caliber, but generally shoot for annealing the shoulder, and due to the neck being significantly thinner, it just comes along for the ride as it will heat up faster. When I started annealing, I did use 750-degree Tempelac, but over time I can just turn off the lights and know exactly where it needs to be set. You can see in the video that I'm heating the brass and the blue flame will just briefly change to orange and the neck just to the point where it's starting to glow. At that point it's done. It needs to be pulled from the flame. For gas, I just use a hose with a 1/4 inch T-fittings placed in and hooked up to a 20-pound cylinder. 20-pound cylinders are far cheaper to fill than single-use cylinders, and due to a lot more gas in the tank, they produce a much more consistent flame length. First off, let's circle back to the start of the video. I do think that if you need something out of the box that you can load up, walk away from, and not spend a small fortune and not have to tinker with, the Annealer is a fine solution, and it is 100% American made. Maybe I just screwed up something and that's why I had issue with 300 PRC. Either way, my old one went to a friend and he will get years of use out of it. Overall, I'm happy with this annealer. I will say, if you're in the market for a dual torch annealer and you don't mind hand feeding it, it's going to be pretty hard to top this unit for its price. The AGS is obviously not American made as it comes out of Serbia. However, the fit and finish of the unit really are top notch. It fits the use case I need, and I was successful in setting up to run automated with some work. Automation is important to me personally, as I only have limited amounts of time and patience to get my reloading done. So any time that I can save by automating or speeding up a process is something I strive for. I anneal every piece of brass, every firing, as it has increased the lifespan of my brass, as well as the neck tensions are far more consistent. My volume of cases when I do anneal is pretty high, as I only process AR brass for my 223 and 308 once a year. So at that point, it's generally a few thousand pieces of each of those when I get around to it. So once again, automation is a must-have. I anneal the brass for my precision bolt guns quite a bit more often, as I generally have 300 to 500 pieces of brass on hand for stuff like that. And I anneal as I work through a full batch of brass so I can track firings. I do need to give Tyler and the gents at Cast Bullets a bunch of credit. They provided me the idea on this and gave me a good jump off point for the parts I needed. I am awful at 3D modeling, so modifying something that exists is the easiest way for me in combination with something like Tinkercad. The bullet feeder they put together and the parts for the Lee APP are freaking fantastic. I use the bullet feeder and the APP parts, and now use the APP parts as the start for this project. I'll put all the links to this stuff in the pinned comment, as well as the stuff I bought to modify this. The only other annealers I found that could be easily set up for this type of work with a dual torch are a bench source, a sassy brash, or a BC 1000. Of those three, I would have to reach out to bench source or sassy brass to see if they are taking orders, and I know the BC 1000 is not being made anymore. However, the bench source and the sassy brass are also minimum twice the price. I do see that the sassy brass is available set up with a case feeder in mind, but once again, it's well over twice the price. There is also the amp with the amp mate, but I'm not willing to approach $2,000 for an automated annealer setup from them. We won't get into the debate of induction versus flame annealing here, as this is a huge can of worms I'm not interested in opening. Doing some type of high temperature annealing, flame or induction, is better than no annealing at all. I hope this video is useful for those that are either looking at buying the AGS or are looking to jump into automating it. If you have questions, please leave a comment and I'll get back to you. Thanks for watching.